Aggregate method in LINQ. This method is a gem for performing calculations or operations on a sequence of values and aggregating them into a single result. Imagine you have a collection of numbers and you want to sum them up. The aggregate method helps you do just that, and much more. It processes a sequence and applies a function you define, step by step, to come up with a single aggregated result. You can use aggregate for various purposes like summing up values, finding products of numbers, concatenating strings, or even more complex operations in collections such as arrays, lists, dictionaries, and more. The aggregate method comes in 3 different overloads. Each one lets you apply your rule to your group of values in a different manner. Let's look at the first one, which has the following structure. It involves the sequence we want to aggregate, then the method with a lambda expression. The lambda expression uses 2 parameters. The first one represents the accumulator, or in other words, the current state of aggregation. The second parameter is the current element from the sequence. Let's go through an example to make this clearer. Imagine you have an array of 5 integers. Here's how you can use aggregate to add up all these numbers. We will go through each step to understand how it works. In the first step, the variable x represents the content of the first element inside the array, which is 9. And the variable y takes the value of the next number, which is 5. The rule here is to add them together, so 9 plus 5 equals 14. In the next step, x becomes 14, our previous result, and y is now the next number, which is 3. Adding these together gives us 17. This new total is stored in x, and we move on to the next number. Adding 17 and 7 gives us 24. Finally, x is 24, and y takes the last number. Adding these together, we get 30. Since there are no more numbers, the process ends, and our final answer is 30. That's how the aggregate method works to combine a series of values into one final result. The result here is of type integer because we have a collection of integers. In summary, the first overload of the aggregate method works like this. In the initial step, the first parameter, let's call it accumulator, takes the value of the first element in the sequence. In subsequent iterations, this accumulator holds the current result of the aggregation. The second parameter, we can call it current element, is used to go through the elements of the sequence, starting from the second element onwards. Each time, current element represents the next element in the sequence, and the accumulator is updated based on the specified operation. To understand this better, let's look at another example. Suppose we have a sentence that we want to reverse the word order of, using the aggregate method. Let's see how this is done with an example sentence. Imagine our sentence is, learning is fun with LINQ. We want to reverse this to LINQ with fun is learning. First, we split the sentence into an array of words. Then, we use the aggregate method to reverse the order of these words. In the aggregate method, the first parameter initially takes the value of the first word in the sequence, and the second parameter takes the value of the second word. The operation we use here is to place the current element before the accumulator. So, in the first iteration, the accumulator is learning, and the current element is. The result after the operation will be is learning. In the next iteration, the accumulator now holds as learning, and the current element is fun. Performing the operation again, we get fun is learning. This process continues, with each word being added to the front of the accumulating string. After processing all the words in the array, we end up with the original sentence with its words in reverse order. So, learning is fun with LINQ becomes LINQ with fun is learning. The result is a string composed of the reversed order of words. This demonstrates how to use the first overload of the aggregate method to reverse the word order in a sentence. It's a neat way to manipulate strings and can be very useful in various programming scenarios. Now, let's explore the second overload of the LINQ aggregate method. The structure of this overload is the following. This version of the method is quite handy when you need to start the aggregation with a specific initial value, known as the seed. In this overload, the aggregation process doesn't start with the first element of the sequence. Instead, it begins with the seed value you provide. Here's how it works. The seed is the starting point of your aggregation. This value is what your accumulator will initially be set to. The accumulator still holds the running result, but now it starts with the seed value. The current element goes through each element in your sequence, starting from the very first one. In the first iteration, accumulator is your seed value, and current element is the first element of the sequence. The specified operation is then applied, and the result is stored in the accumulator. This process continues with each element in the sequence. Let's go through an example to understand it better. Suppose we have the same array of integers from the previous example, and we want to start our sum with 8. The query would look like this. Here, 8 is our seed. This means, in the first step the accumulator is equal to 8, and the current element is 9. This is the difference between the first and the second overloads. Using seed value, we don't start with the first element of the sequence as accumulator, but with the seed value. The current element doesn't take the second element at the beginning, but the first element. So 8 plus 9 equals 17. In the next step, the accumulator is 17 and the current element is 5. Adding these together gives us 22. And so on, we add the numbers of the array together. Our final result is 38. This is how to use the second overload of aggregate method. Now, let's explore the third overload of the LINQ Aggregate method. This overload has one function more than the second overload. This function is to transform the final accumulator value into the result value. So, it's also a lambda expression that takes only one parameter. Let's take the same array example to understand this overload. Suppose we want to do exact the same like the previous example, but at the end we want to multiply the result by 10. Here's the query to do that. As you can see, I used a new lambda expression with only one parameter. Here I am multiplying the result by 10. Let's see how does it work. Such as in the previous example, we first sum up the numbers to get the result, which is 38. After that, using the lambda expression we have the following calculation. The parameter result selector represents the result, which is 38. Multiplying this parameter by 10 gives us 380. So, the final result of this query is 380. In this way we transform the result into a new one. Let's explore another example to understand it better. Suppose we have a list of words, and we want to concatenate them into a sentence, and then convert the entire sentence to uppercase. Let's see how this works. Here's the query to do that. We will start with an empty string as our seed and concatenate each word to form a sentence. Initially, accumulator is an empty string. The first word, LINQ, is concatenated, resulting in LINQ. In subsequent iterations, is and powerful are concatenated, forming LINQ is powerful. Finally, the result selector function transforms this string into LINQ is powerful. So, using this overload of the aggregate method, we have not only combined the words into a sentence but also transformed the entire sentence into uppercase. This shows the power of the third overload, where you can manipulate and transform the aggregated result as needed. Let's now summarize the overloads of aggregate method. The first one takes only one parameter, which is a lambda expression with two parameters. It starts with the first element of the sequence as the initial accumulator value. The accumulator then aggregates each element of the sequence one by one. The second overload begins with a seed value as the initial accumulator. The accumulator aggregates each element from the first one onward. The third overload is similar to the second overload, but allows for a final transformation of the aggregated result. Before we conclude our exploration of the LINQ Aggregate method, let's touch on some important considerations. The first point is the error handling. It's important to know how to handle errors when using aggregate. If you try to aggregate an empty sequence without a seed value, or in other words, using the first overload, you will encounter an invalid operation exception. Always ensure your sequence contains elements, or provide a seed value to avoid this error. This means, don't use the first overload. Please also note that all overloads throw an argument null exception in case the source is null. Next, the performance of aggregate method. While aggregate is versatile, it's not always the fastest option for large datasets or complex operations. In such cases, specialized LINQ methods like sum or max might offer better performance due to their specific optimizations. Alternatives to aggregate. For simple aggregations, LINQ provides methods such as sum, average, min, max, and count. I already explained these methods in the previous videos. These should be your go-to options because they are more straightforward and can be more readable than using aggregate. For example, if you only need the sum of a list of numbers, numbers.sum is clearer and more concise than using aggregate. One last thing I want to mention, that I use the aggregate method only with arrays and lists, but it can be used with any data type, such as data tables, XML, dictionaries, etc. That's all about aggregate method.